This is the first type of problem. Again, I think this is the most likely problem you're going to see on the AP test. I think it's the most likely one you're going to see in terms of things go in, things go out. In this case, we've got the rate at which people enter an auditorium of rock concert is modeled to the function r, given by the function r of t is equal to 1380 t squared minus 675 t to the third from hours 0 to 2. RT is measured in people per hour. Now, all that says, look, I've got a rate here, which means if I take the derivative, I can have the rate of the rate. If I integrate, I can get the number of people in the place, correct? This is the game. This is the game they're going to play with you. They might like to ask the word average. They might do something like that. But the bottom line is you're pretty much looking at the same old problem repackaged. Honestly, if they don't ask this question, it's a crime scene. So my guess is this is the question, both it's going to appear as the second question on the C test, on the BC test, and the first question on the AB test. That said, let's do the problem. All right, RT is measured in people per hour. No one is in the auditorium at time equals 0 when the doors open. The doors close and the concert begins at time equals 2. How many people in the auditorium when the concert begins? Okay, so they give us a rate of people. So therefore, the integral would give us the number of people. So our people is going to be equal to the integral from 0 to 2 hours, because that's how long we're piling up people in the anteroom, of 1380 t squared minus 675 t to the third dt. So I get raised power by 1 divided by power I get. So I'm going to shorten this down because I don't really want to watch me do divided by 3 problems, as much fun as that is. So I got 460 t to the third minus 675 divided by 4. 168.75 t to the fourth from 0 to 2. Plug in a 2, I get 460. 2 to the third minus 168.75 is a decimal point here. 2 to the fourth equals, and I get 980 people. Okay, so again, give me a rate, how many people, it's the interval. Okay, B, from the time at which the rate, from the time when the rate of which people enter the auditorium is maximum, find the time at which the rate at which people enter the auditorium is the maximum. How do I find when the rate, which is the equation they gave me, how do I figure out the maximum rate? I'm going to integrate, set the integral equal to 0 to find my critical points and find the highest value of that set. Yeah. Oh, you'd have a calculator for this, so you could actually totally use the calculator to find it. The problem with that is, how do you show that to the people in charge? So now I'm going to go do A, or do problem number B. Problem number B is find the rate of which. Okay, so I'm going to take the derivative of this monstrosity. So if R of t equals 1380 t squared minus 675 t to the third, I'm going to reduce its power by 1 and multiply by power I've got. So that would be 1380 times 2, which is 2760. 2760 t minus, and then I've got 3 times 675, so I've got 2075. 2075 t squared. 2025, sorry, 2025, that would be better. T squared, and I want to figure out that's a maximum, so I set it equal to 0. I know how to factor it. One of them is going to be t equals 0, which is darn convenient because I can pull out a t. The other one's 2760 minus 2025 t, right? And so I'm going to have t equals 0. So set each of these equals 0, t equals 0. And 2760 minus 2025 t equals 0. I move that across. Negative 2025 t equals negative 2760 2760 divided by 2025 gives me a whopping 1.362 something or other. So the other one's t equals 1.36296. Now again, I'm not sure how picky they're going to be in this current environment, but you should choose to check all three of the endpoints. So you should say, well, time equals 0 is important because it's a critical point and an endpoint. It's doubly important. 1.36296 is important, and 2 is important, right? So then what I'm going to do is I'm going to get out my calculator, because I did my calculus problem. I table it, type the equation in. When I type the equation in, this equation here, right, the rate, I'm going to get that my 0, I'd have 0. 854.527, remember 3 past the decimal point, and then 120 are the 3 numbers I get. So obviously my maximum is this, the maximum number of people. The question is, what time? What time would be 1.363, right? 1.363 hours. When I'd have my maximum time. All right. I'm going to have to clean up my desktop a little bit, so I'm going to go ahead and do that. All right, so now we get to the land that I'm a little bit worried about when it comes to your AP test, and that is they want to make sure that there is 0 chance you can Google answers, right? They want to make sure that there's 0 chance Wolfram Alpha will give you an answer to anything that you shouldn't be able to do with 2 seconds. So therefore, this is a problem that is disconcerting, and as this one. It says the total wait time takes the total wait time. That's when you take all the people in the auditorium. So in other words, you add up every person times how much time they were standing there. This guy is 20 minutes. This person's 60 minutes. So 20 plus 60 plus this person waited 80 minutes. And then you got to do it for every single person in the thing. The total wait time auditorium is the time each person waits, starting at the time a person enters the auditorium to when the concert ends. The function W models the total wait time for all the people in the auditorium for time equals t. The derivative of wait time is given. Okay, so now here, look. They've given us, like, I'm trying to figure out what to do, and the answer to the question is, hey, this is wait time, or the derivative of wait time. So I don't really have to work that hard, because RT, which by the way is 1380, t squared minus 675 to the third, whoop, and there that loveliness is. Find the difference between wait time the total wait time of people that waited for this during the second hour, essentially. So, because they want you to subtract the wait time for wait time 1. So, all the people in the audience, how long did they wait? Total amount of time they waited. Well, scratching my head, all I want to know is what wait time is, right? How do I get for wait time given derivative wait time? Well, I'm going to integrate it. I'm not going to think too hard on this. And honestly, for this problem here, now that we know how a calculator works, 675 t to the third, I would slap this in my calculator, put a 1 and 2 here. You can do it by hand. It takes a while. And the answer you would get if you do this right is 387.5 hours. That's the total wait time of all the people standing around between hour 1 and hour 2, including those people that arrived later and walked in and stood there for a long time. On average, how long does a person wait in the auditorium for the concert to begin? Consider all people in the auditorium after the doors open. Use the model for total wait time found in part C. Okay, average. Now this one's nasty, because they're not asking what's the average per time. They're asking for average per person. So this is a really wicked problem, and this is why they asked this question here, is because they wanted to ask this really wicked question down here. So what do? Average wait time is going to be wait time average. Okay, the wait time average would be 1 over 980, right? That's the number of people. Integral from 0 to 2, we're going to do from 0 to 2. And then we're going to take our wait time formula, our wait time derivative, which is 2 minus t. 1380 t squared minus 675 t cubed dt. All right. They're not going to ask this question again. Okay, they're not. It's just that simple. They're not going to ask that question again. But you need to be aware they're going to ask a question that's like off the charts ridiculous, right? It's something that you did not expect to see. Okay? All right. So you want to find the average wait time. You're going to have to find the total wait time, which now is between 0 and 2 hours. You're going to divide it by 980 to figure out how much each person waited. It is the one place where the average formula is going to completely and deceptively fool you into thinking you've got the right answer. So all I need is the wait time, which is this interval gives me, divided by the 980 people standing around waiting. All right? Alrighty then. I think I've got this problem licked. I will post this.